Excellent. So we have Dr. John Lewis joining us for the class today. And Dr. Lewis, I would like you to tell the students a little bit about your career, okay? Especially kind of when did you decided that you would become an astrophysicist? And what have been the paths that your career took you to the point where you are now, considering also, your experiences even from elementary school or high school?
Well, that's a very long story because I decided I wanted to be a space scientist when I was 3 years old. And it all consisted of seeing the moon and asking my mother whether the moon had a face on the other side. And she gave me the perfect answer. She said, "Nobody knows." So at that point, I decided that there was actually work to be done in the field and I might as well follow my interests. I got a bachelor's degree in chemistry from Princeton with a minor in astrophysics, a master's degree in inorganic chemistry from Dartmouth, and my PhD from the University of California in San Diego in geochemistry and cosmochemistry. My thesis advisor was Harold C. Urey, who is a very famous.
Okay. I just lost the audio there when it said very. Oh, I may have blundered that part, that first part. Okay. Mm, So, Dr. Lewis, are you still there? I cannot hear you. Okay. Oh, these things always get tricky with the technology. Dr. Lewis was saying that he said, okay, all right. Dr. Lewis was, okay, go ahead.
Um, the things that you're saying are not getting well. It's constant interruptions, dropouts of the audio.
Oh,
So
so
I gather you just want me to continue talking. Is that
yes, if you could start,
is that correct?
okay. Yes, from the beginning when you were talking about, I think that we lost you at the point where you were saying that your the advisor in your dissertation was Dr. Urey.
Yes. Upon receiving my doctorate, I took a faculty position at MIT in what was then the Department of Earth and Planetary Sciences. And in that, I became an advisor to NASA, a member of a number of different NASA advisory committees.
Okay, let me see. I'm going to unmute just Dr. Lewis and see if that
Professor of Planetary Sciences at Arizona, and retired about 7 years ago from Arizona. And I'm now the chief scientist for Deep Space Industries. My whole career has been devoted to the application of chemistry to problems in astronomy, the study of the solar system, comparative study of the planets, the origin of the planets.
Okay, we still are having some audio trouble here once in a while. Okay. Go ahead.
Well, that.
All right. So the beeps that come in and out are some of the connections coming in and out. Okay. But we hope that that doesn't affect the audio, but it seems that it is sometimes. Okay, let's see. Dr. Lewis, are you still there? Mhm.
Yes, I am.
Okay. If we are having problems communicating here, in this planet, do you think that we'll be okay trying to do this um, with between planets and asteroids moving at very fast speed? The challenges are plenty, aren't they?
Well, when we're communicating over interplanetary distances, we have much more expensive equipment at our disposal.
That's awesome. That is good. Uh-huh. If we are having still problems with the audio, okay, another possibility would be for you to call in using the phone, okay, number, and sometimes that is a little better, more stable through the phone, okay. Mm-hmm. So okay.
All right, I will leave Skype now and try to call in, okay?
Yeah, that would be probably best. Let's try that. Okay.
Okay.
So in the meantime, what I would like is I received some questions from Emmeline, okay? And I would like you, Emmeline, to be ready to ask these questions when you're ready. Do you have a microphone, Emmeline? If you can unmute yourself and tell me, or you can put it in the chat.
Yes, I can.
All right.
I do have a microphone.
Excellent. So I want you to be ready to ask your questions, okay, to Dr. Lewis.
Okay.
All right, when we have him back. And also explain what you know about S-type asteroids and what do you know about the delta V requirements for your missions, okay? Would that be all right?
Yes, it will.
Excellent. Then we have Nathan. I want you also to be prepared to ask this question: how can you use the near-Earth objects as positive resources? All right, and we'll try to expand from there. And then we'll have some time. Also, I would like Rodney for you to ask some of the questions. Okay. For now, I would, but I can. My microphone doesn't work. Okay. All right. So Mia, if you have some questions, you can type them here in the chat. All right. I can ask the questions. So Rodney, do you have your microphone also?
I do have my microphone on.
Excellent.
Do you think I should ask all those questions, or do you think we should just?
Let's. I would like to concentrate here on the space exploration for now. All right.
Okay.
If you
have, I was realizing that I was like, I have a lot of questions. Maybe we shouldn't answer every single one of them.
No, that's right. So I think that let's concentrate here probably on the mining of asteroids. Okay. So like this question, do we have the technology to actually recover minerals from space? All right. Okay.
Yeah, I can ask that one.
All right. So Dr. Lewis, when you are ready over the phone, please let us know. Okay. So this is what happens with technology, okay, and some of the problems that need to be worked out many times over, okay. Okay, so let's see. Dr. Lewis will probably either start talking when he joins us over the phone, or he may appear also in the list here. Mhm. Okay. Mhm. If anybody else has questions that you would like to add here to asking, you can put them in the chat, and I will try to also put them there. Okay. So. Mhm. I am very curious about some of these technologies here of deep space.
Minerals. Minerals means anything. Gold, silver, iron, nickel.
Yeah. So
I said minerals just to clarify everything.
everything, yeah, really the whole thing. The question that I have here, Sabrina, that I think that I would like you to ask, all right, or I can ask for you, is about the issue of transportation. Okay, so I can understand how we can do the prospecting, even some of the harvesting. Okay, and it seems that some of the processing that this is proposed is actually to happen in space. Okay, but if we actually want to have the resources, available at some point, we have to bring them to Earth. Okay, unless we use these resources just for manufacturing things and processing things in space. All right. So my main question is, so far the re-entry into the Earth's atmosphere has been very, very difficult. Okay, and so that is what I would like to find out. How do we do that? Okay. I would like also to know if he were in your situation, in your position as a homeschool high schooler, what would he recommend for you to study and learn in order to prepare for a career, possibly in space science?
That was a good question. I'll have to ask that one.
Okay. Okay. So Mia, what do you mean with when you say how would we mine minerals without gravity? What would gravity do one way or the other to the process? Okay, that is one question that if you want to clarify. So Annika, you have here a question, can you video anything in space? All right, anything that has light, yes, you can video. All right, even, that mostly whenever we see something in space is because it's reflecting some sort of light or emitting some sort of light from the infrared spectrum. Remember when we were talking about the infrared spectrum is the cooler side of the spectrum. Okay. So, do we have Dr. Lewis back? So, I don't think I have seen him. So the nebulas, you also ask about if we have a video in nebula. What we have actually is pictures from the Hubble Space Telescope and from other telescopes. Remember when we were talking about the infrared telescopes that actually are able to capture the very cool frequency of light emitted by the nebulas. So all the pictures like this one here of a nebula, these are not artistic renditions, they are actually actual pictures taken from telescopes, but they are really using the infrared light in order to capture the faint emissions of light of these clouds of dust in the space. Okay. Also, you had another question here, Annika, is also if we bring things into the Earth atmosphere, will it displace air? Yes, it will. Okay, of course, anything, any body submerged in another body displaces. Okay, it's like when you put a rock in a swimming pool, it displaces displaces the same volume of liquid, okay, as you would the volume of the object immersed. That is the Archimedes principle, really, and that is how Archimedes figured out how things float and everything. And so that is a very important principle. The issue is, I guess, if you are asking if it displaces air out of the atmosphere, I don't think that it would make much of a difference. Okay, as we were looking at, we have tons of dust and space dust that enters, about 100 tons of dust that enters the atmosphere every day. So it wouldn't make much of a difference. So we already have a lot of things being added to the atmosphere of the Earth every single day. Okay, and we haven't seemed to notice much. So bringing an asteroid, even if it's a large one, but in some controlled manner, it would still be fine.
Pablo?
Yes.
I was able to connect successfully on the telephone. I could hear everything everyone was saying, but you couldn't hear me.
Oh,
so I'm
okay.
Back on Skype again.
So you're back on Skype. All right, let's see if that works out. Okay. So, yeah, I think that what you need if you call on the phone is, okay, hold on. Opa. So it's the audio pin. Hold on a second. Okay, if you let's see. Okay, so if you are back again, if you connect on the phone, you need the audio pin for the meeting. That is 52. Okay, all right. So, but let's.
I connected.
Oh, you
Pablo,
connected?
I connected on the telephone. I was able to hear everything you were saying, but you couldn't hear me.
That's frustrating. All right. Well, let's continue and hope that this works. Okay. So we have some questions for you. Emmeline, would you like to ask your question to Dr. Lewis?
Sure. Do you want me to do just one of them?
Let's start with the first one and see where we go from there.
Sure. Let's do number one. S-type asteroids, stony asteroids, are probably pretty closely similar to what are called chondritic meteorites. They contain up to 30% metal. This is not just metal ores, but this is actual natural stainless steel, iron, nickel, cobalt alloy with a number of other trace elements dissolved in them. So the S-type asteroids would be wonderful targets for any
See, Skype attacks again to us. Yeah. Okay. Yeah.
Is he reading the questions off?
Well, so I'm showing the screen. Okay. So next time I will try to let you have the chance to ask the question. Okay.
Okay.
Okay. Yeah. And then show it on the screen. So, all right. So why do you think that, what was he explaining about S-type asteroids that would make them a good target for mining?
They have natural things. Very cool.
Go ahead. Emmeline, go ahead.
Oh, I was about to say it was basically the same thing. Metals, just because some of them are so valuable.
Yeah.
So yeah, just basically what I was gonna ask.
Yeah, that's right.
But what I really wanted to know was how you mine them. Like if they break off the chunks, or if they melt it down, or just how that works.
Excellent. Yeah. So that is the question that I would like you to ask. Okay.
My audio.
Yeah. Now we are back again. Briefly. Okay. Let's see.
About every 30
Oh,
seconds,
yeah.
connection has been lost. That plus the fact that you can't hear me on the telephone makes this rather difficult.
No kidding. We should have practiced this before, Dr. Lewis. I think that was my fault.
Well, I use GoToMeeting all the time, and this is pretty challenging.
Yes.
All right. We were talking about how you mine an asteroid. Basically, assume that mining on an asteroid is on Earth. In mining on Earth, you're operating in a strong gravity field. On Earth, we have easy access to air and water. We have lots of gravity. So what's different on an asteroid? Everything. What we probably would not have to do is to find a vein of minerals that we want to mine. Instead, we would find that the entire asteroid was pretty much homogeneous, that it didn't matter which piece you tried to process, it would all have very much the same composition. Almost all asteroids are primitive material. That means it's never melted and separated by density the way the Earth has. On Earth, the evolution of the planet has caused extensive melting of the interior, and the dense materials have settled to the center to make a core. Very few asteroids have that situation.
Because
very few asteroids have melted and separated. Therefore, the typical asteroid, the S-type asteroids, for the most part, will be pretty much homogeneous. So you don't have to hunt for veins of minerals. You don't have to dig deep. What you have is a surface that has been crushed by impacts. Asteroids collide with each other. Small chunks of asteroid material collide with asteroids all the time and crush the surface material, producing what's called a regolith. And a regolith is just a surface layer of crushed material. So the kind of mining you would use might be to simply use an electromagnet to pull the metals out of the crushed material, out of the dust. Very different.
Okay, so you would actually just gather the minerals right there from the dust on the surface of the asteroid with an electromagnet. Very interesting.
Right. Just.
All right.
Oops. Okay. All right. Let's see.
All right, next question here. Is it true that you have delta V requirements for your missions?
Yes, hold on. Go ahead, Emmeline. Ask your question. There's another one that Emmeline wanted to ask for you.
Okay.
Yeah. So, I mean, you can answer the second one, but I was just wondering because list of, the delta V that you had to have and how, that affects your mission and how, I guess not necessarily affects your mission, but I guess that kind of affects the cost, I would think. Is that right?
What would affect the cost?
About 90% of what you actually said because of the dropouts on the connection. You're asking about the
Ah, okay. Yeah, so I can see that Dr. Lewis's connection comes offline and online periodically. Okay, for some strange reason. All right.
Hear me at all?
Yeah. Go ahead now. Aha. Go ahead now. Let's see. Okay.
Can you hear me now?
Yes.
Okay. Answering the question about delta V requirements, which I'm reading, couldn't hear the question.
This is so weird because normally we don't have that many problems. Okay. Okay. Let's see. I still see that. Okay, now he came on offline. Yeah, part of the problem, I think, also is that we are reaching kind of the limit of people that can attend this meeting. Okay, and so I think that is also may have an effect on things. Okay, so let's see. Okay, Dr. Lewis, are you back?
Hello?
Yes, go ahead. I would like to ask one question that we all have was about the issue here on mining is, do you mean to bring the minerals back to Earth, and how would that be accomplished?
Hello?
Go ahead.
Right. Can you hear me?
Yes.
All right, I heard the first part of your question. Can you hear me now?
Now I can hear you, yes.
Okay, the first part of your question was, would you bring minerals back to Earth? The main purpose of these activities in space, provide propellants and metals for use in space. There are very few materials that are worth the expense of bringing back to Earth. An example would be the platinum group metals, which are extremely valuable, several $1,000s an ounce. But most of what we would be doing is extracting water, carbon compounds, and so on from asteroids to manufacture rocket propellants and to manufacture life support materials, air and water and agricultural chemicals for use in space. So generally, we would be processing the minerals in space. Very few of these things would be brought back to Earth. There is a large demand for rocket propellant in orbit around Earth for deep space missions, for missions going to the moon, to Mars, and back to the asteroids. We would be able to provide propellant in space, in orbit around Earth, for use by those missions. And that's one of the purposes we have. Bringing back minerals, what we might bring back is the very, very valuable materials, the platinum elements. We would bring them back as a powder of mixed platinum group elements. That's platinum, palladium, osmium, iridium, rhenium, and so on, all of which are extremely valuable and rare commodities. We would be bringing them back and actually doing the chemical separation of those elements here on the ground.
Excellent.
Pretty much everything else would be done in space for use in space.
For use in space. That makes a lot more sense. Now, could we harvest enough chemicals to actually build small atmospheres or small places with atmospheres like in Mars or the Moon?
Yeah, there are. I only heard part of your question again. You know, I'm getting about a 90% dropout. But let me say that on Mars, one of the things that we would like to be able to do is to manufacture that we could, for example, build domes on Mars for human.
Okay. Oh, we have that.
He's talking, but we can't hear him.
Yes. Okay. I think that we have.
Phone again.
All right. So you were saying about Mars that we would be able to build domes.
Yes, we would build domes, and we would be able to provide them with air, water, and agricultural chemicals.
Wow.
So we could make a Mars colony self-sufficient, growing its own food.
Now that is very, very interesting. Okay. Rodney, do you have your question? Would you like to ask Dr. Lewis your question? See if we can get that.
Yeah, I have it. It's, do we have the technology to actually recover the minerals, or since you've already explained that you'd use it for in space, do we have the technology to use the minerals from space and start making them or start using them? Do we have that ability right now?
Okay. All right, let's see. Now I see Dr. Lewis offline again. Okay, so I think that one part of the problem is again being close to the limit here on the GoToMeeting lines. Okay, so we may need to upgrade this account to the GoToWebinar when they can handle more than hundreds of connections at the time. But I think that is part of the problem. Okay. So now this was very interesting to hear and to understand now how the mining is actually a processing, really in place. Okay, so the idea is actually to do the processing of the minerals right there in space. Okay, so here we have a diagram from a DSI website that would show, okay, how the minerals are crushed into sand. Then by magnetic density, there's a separation. The metals are stored, and probably those are the ones that are more valuable, the heavy metals especially, and they could be transported back to Earth. All right. So now we are not talking about bringing a whole asteroid to Earth, but just the specific heavy metals that are more valuable. Then we would have other processes to take out the solids, okay, and then another process for refining liquids and gases, and being able to, through electrolysis, okay, convert water into oxygen and hydrogen and carbon compounds, okay, would be able to then make them and see to make them into fuels, okay, like especially rocket fuels for the space travel already there in space. So very interesting approach to that. Okay, I don't see Dr. Lewis online. All right, so we will continue, but this seems very interesting. Okay, that when you think about it, remember in the lesson where we talk about space exploration, about the fuels. Can anyone remember what was the fuel type? Okay.
The main type they used the solid and liquid. It was the pure oxygen and kerosene mix syringe, and then it went to a solid aluminum something.
Yeah, so in the 60s, okay, you are correct. In the 60s, the Saturn V rocket that went in the mission to the moons, it used kerosene, okay, for that. So that is a hydrocarbon. So here we would have that type of fuel coming from carbon. But then I remember that for the space shuttle, the boosters there that provided most of the energy of the space shuttle, I think that Sam was mentioning that they were powdered aluminum, all right? So here you have using probably a metal together with some carbohydrates, or fuel oxidizing material in order to provide power for rockets. Okay, so that would make sense to be able to find that type of fuel right there in space and not have to transport it. Remember, once you are in space, you don't need a whole lot of power to actually propel you quite a bit. Okay. So it seems that Mia, you keep having a lot of problems. I really apologize for having so many technical difficulties. We didn't have that bad before. All right. So, but people seem to be coming in and out, okay, of that. But remember, so most of the fuel is necessary right at the beginning of the space trip to escape the Earth atmosphere. Once you are in space, you probably also need some fuel in order to speed things up, to accelerate, to change your velocity. But once you are in space, moving at some certain speed, you continue on that speed without any slowing down, all right, until something else happens, until you get close to another planet or something like that would change your orbit. But so it makes a lot of sense to be able to try to harvest these fuels in space. You don't have to lift them up, take them out of the Earth atmosphere, and that is where most of the burning actually happens. So that makes a lot of sense. So you would be able to have a probe or a rocket going out of the atmosphere and then trying to provide extra fuel once you are out in orbit. Yeah, I imagine that he is probably trying to connect. Okay, so I don't think that he has given up on us, So I keep hearing the in and outs of the people trying to connect and trying to see here on the list of people coming, but I don't see which one is which. Okay. So,
Unmuted.
Yeah. Okay. You could end the meeting and ask everyone to exit and re-enter using the same link. Yeah, this has never happened before. Okay. What do you mean, Mr. Anderson, by the same link? I don't know.
I mean, that it may be that we could all just end this meeting.
Mm-hmm.
If you start right away, the same link that we always use, the same meeting number still works. And so maybe there's something going on that, if we were to just end it and then restart it,
Okay.
maybe our issue with Dr. Lewis would be solved.
Okay. I
I
didn't
don't know.
change.
It's risk.
Yes, I didn't change the meeting number. This is the same meeting as we have always
That's
used.
right.
Mm-hmm.
That's right.
Okay. So this has not. So shall we try that? Okay. We want to risk it.
I would again just click on the same link. You'll be back together within about 1 minute.
Okay, let's do that. I'm
Fix the
going to
problem.
leave the meeting, okay, and then we'll
Down.
join again. Mhm. All right. All right. So this is one for the keeping, really. Okay. So the science meeting again. All right.
You will now hear beeps until someone else joins the conference.
Okay. So we have a lot of people already in the meeting. I was probably just the only one disconnected, and everyone connecting again. Okay. So let me see if I see any emails from. Okay, so I see an email. I have phone it, but I am muted. Okay. So.
We'll have to start the recording again.
Oh yes, to show the screen. Mm-hmm. Yeah, okay. So Dr. Lewis sent an email saying that he's phoning again, but he's muted. Okay. So, and I don't have him in the list of people in the meeting. Go ahead.
He needs to use an audio pin, and the audio pin he should.
Yeah, he said that last time when he said that he tried with the phone, he said that he did have the audio pin. Mm-hmm.
Hi, Dr. Lewis. Can you hear us? He's here. Dr. Lewis, can you hear us okay now?
I am here. I
Okay.
am alive. I am.
All right. Okay. All right.
I can hear you, and I think you can hear me.
Yes. That's right. So let me show.
Are we ready to get rolling again?
We are, by all means. Mm-hmm.
Okay.
I can't see anything on my screen. There we go. Never mind.
Mm-hmm. Yep. Okay.
And GoToMeeting just gave me a message that says you may be experiencing network connection difficulties.
No kidding.
Oh, joy.
Yes. So the question that Rodney had is if we actually now have the technology to do these things, or this is in what stages of development is this technology now?
They sort of take that apart. The basic spacecraft.
Okay. Oh, we had him for a second. We had him for a second, and now we are missing him again. Okay. Let's,
Okay. Okay. That's actually a more difficult feat than landing on the typical near-Earth asteroid.
Yes.
And one of the reasons that the nearby asteroids are so attractive is that many of them, literally thousands of them, are more accessible for a spacecraft traveling from Earth than the moon is. So if we're interested in sources anywhere, the best place to look is the places that are easiest to get to, have desirable composition. Mm-hmm. The mining techniques that we would need in low gravity are probably things that need to be tested thoroughly before we try to develop them commercially. But we have excellent ideas, I think, about how to handle the materials, how to separate them, how to process them chemically, how to get useful products out of them. It's simply a matter now of demonstrating them in microgravity. Mm-hmm. That's the challenge. The amount of money that's required to actually do these tests is millions of dollars, not billions, not trillions. But the value of the resources that would be made available to us if we could mine these asteroids is multi-trillion dollars worth of resources. So there's every incentive here for people to invest those millions of dollars needed to prove the technologies, and then hope to own a share of the profits from doing it on a large scale.
Mm-hmm. I have a couple of questions. One, Nathan asked the question if would a public, like a NASA type of enterprise would be more likely for this, or private enterprise?
NASA, as a government agency, is excellent at taking care of its own budgetary needs and has absolutely no familiarity with operating in a marketplace. NASA is supported by tax revenues from unwilling taxpayers, and willing taxpayers, I might add. Mm-hmm. But for a government program manager to seek out a way of doing things more economically and more efficiently would probably be grounds for his firing. We so frequently see government program managers choosing to do things in a very expensive way because their prestige as managers is associated with the number of dollars in their budget. Mm-hmm. So I would be appalled to see this become a government. They have no experience in doing anything economical and in selling anything to the public. They are not oriented toward cost containment or to profit. Mm-hmm. So my sincere hope is that NASA will do what it does well, which is providing basic scientific knowledge and leave the economic exploitation of asteroids to commercial entities who know how to do it and who will be concerned about minimizing the costs and minimizing the price of their products.
Absolutely. Excellent. Okay. The other question that I have
and by the way, the proper role of the government in this is that they will receive payments of the taxes paid by these successful corporations.
So it would be quite a bounty for the governments that support and kind of provide the mechanisms to get out of the way for that. Mm-hmm.
Yes, that's certainly true. And one of the things that our company is involved with doing is talking to governments around the world and trying to find out ways in which we can proceed with our plans without some government trying to block it out of sheer jealousy or out of greed.
Mm-hmm. Yeah, absolutely. Excellent. One question that came up, okay, is if you were to put yourself here in the place of these students, so these are young Latter-day Saint homeschool students, okay, that are in high school, what would they have to do to study and to prepare to probably plan or to enter in a career in deep space exploration?
Yeah, that's quite an interesting question. I was part of a television special produced some years ago that was called Living and Working in Space. If that's still available, you might want to view it because it addresses high school age students and it addresses the issue of how they should prepare for careers in space. In the long run, just about any career that you pursue here on Earth will have applications in space. But in the short run, it is the people who will make it possible to live off the land who will understand accessing and mining and processing materials.
Mm-hmm. Okay. So there's a lot of potential, really.
Collected in space.
Yeah. Mm-hmm. So there's a lot of potential for many different types of careers here.
Whether they're interested in the right.
Mm-hmm.
Whether their interests are scientific or engineering or economic,
mm-hmm.
one thing they all need in the development of space is mathematics. Mathematics is the foundation for all of those disciplines. And then if you are heading in the direction of science and engineering, then there are, of course, courses in the basic sciences that absolutely would be required.
Mm-hmm.
Generally speaking, successful engineers have a good background in physics or chemistry or some other core science, in addition to the area in which they're applying it in engineering.
Mm-hmm.
So in the near term, I think the quantitative sciences, the science, technology, engineering, math, the STEM curriculum is the key to getting involved at an early point. But I think if you look a generation ahead, we will be seeing a civilization developing in space with every conceivable niche in that civilization occupied by people with very different kinds of training.
Amazing, really. Benjamin from Hawaii asked me a question related to that. He's asking, how long will it be until there is a dome built in Mars? Okay, how long do you think until people can go to Mars?
This is an absolutely impossible question to answer because it depends upon political and economic decisions that have not yet been made. However, I can tell you how soon it could be done. It would be possible to land people on Mars within 10 years and to begin experimenting with human presence on the various methods of building and processing materials on Mars immediately upon their arrival there. This is something that could be done within your time frame.
Okay, so this is well within their life's expectations, something that they could be participant of. Mm-hmm.
It is, but let me tell you a brief story here. Back in 1964, when I was a graduate student at Dartmouth, the NASA sent out a solicitation for applications to the second round of astronaut qualifications for the Gemini program. I wrote away and applied for the application materials for the program, and they sent me a big fat package. I opened up the package, and the first page in it said, "Unless you have 20/20 uncorrected vision, stop here." So I stopped there. My purpose in applying was that I wanted to be a space scientist. I had been planning this all my life, and I wanted to be the first.
Sorry, you said that we cut you the audio call.
Scientist to go to Mars.
Okay, so you wanted
Mars
to be
by 1984.
Wow. You wanted to become the first scientist to go to Mars. Okay.
That's right.
Yeah.
Back in 1964, and as you probably know, that didn't happen. All right, now let's fast forward in time.
Okay.
Graduate of the Air Force Academy.
Mm-hmm.
He says he wants to become a scientist so that he can then become a scientist astronaut and be the first man to go to Mars. That was 1981. This student's name was Tom Jones. He later became a scientist astronaut. He installed the science module on the International Space Station. He flew 4 shuttle missions, and he's now retired from NASA. And he's written his books to
Mm-hmm.
inspire children so that they will.
Okay, let's see. All right. So you were telling about Tom Jones, that he became actually an astronaut in the International Space Station. Mm-hmm. Let's see.
I've lost you completely. You said Tom Jones, and then it went silent.
Yes, same here. So yeah, he became an astronaut in the International Space Station. Okay, so he didn't quite make it to Mars, but actually he did go to space. Mm-hmm.
Yeah, I can hear you.
Yeah.
Mm-hmm.
Yeah, I'm here.
Well,
Okay.
I think he's the only one that's gone right now.
Okay, let's see.
okay.
Oh, I can hear his voice.
Yeah. We can hear you, Dr. Lewis.
Okay,
Mhm.
well, I'm here, but I'm not sure what I'm supposed to be saying because
Okay.
I heard from what I did.
So I think that what you wanted to probably explain from this story is that you still need to dream big. Okay, things may not evolve or happen exactly as you plan. Be it whether we don't have the right vision or the right moment in time. But still, we can accomplish great things and do awesome things in our lives by actually preparing and being ready for that.
Yes, and one thing that's happening now is that private companies are offering relatively free or very inexpensive access to space. They are making it far easier for commercial entities and for private citizens to get into space. This is a very important breakthrough. It gets access to space out of the hands of governments. Governments have a tendency to want to prevent anyone else from being up there. They want to be the dominant forces in space. They want to control the access and the cost of getting into space. But we are now in a new era in which it is possible to actually buy launch services on the open market and to launch payloads of your own. That's one of the things that our company will be doing. We will be buying launch services from low-cost launch service providers and sending off our spacecraft. You will be seeing spacecraft launched as part of this process of getting to the near-Earth asteroids. You'll see spacecraft being launched by private companies within the next year or two. It's very imminent. These will not be manned missions. They'll be small exploratory missions, but we will at last be operating independently.
Excellent. Mm-hmm. So do you think that the government is going to dismantle NASA?
There have been threats of NASA being dismantled going all the way back to the Carter administration. A friend of mine was the president's science advisor during the Carter administration, and I remember talking to him about the idea that NASA could be taken apart. I don't think it's going to happen, no, but I think I think if you look closely at NASA, you'll see that NASA's way of doing business is changing. They're now much more willing to contract with private providers of launch services, private builders of spacecraft, and when they launch a mission that has some extra payload capacity aboard, they are going out of their way to make that payload capacity available to private companies for launching their own vehicles. It is really a whole new world out there, and I am very optimistic about how we will progress in the future.
So NASA could become one of the providers also for launch capacity.
NASA is already doing it.
Okay. Is there or will there be a regulatory agency to coordinate space orbits?
That's really not necessary because the missions that we're interested in are in orbit around the sun, and there's no traffic control problem there. The one issue that may require some kind of regulation is staking mineral claims on asteroids. And it would be desirable to have some kind of an internationally recognized agency in which people can record their claims. If you land a multi-million-dollar spacecraft on an asteroid for the purpose of exploiting its resources, then you want to have the guarantee that you will be allowed to operate on that asteroid and there will be no interference with your operations. This principle of non-interference is actually built into the space treaties that have been signed by many nations around the world. So that idea of non-interference is fine, but it would be highly desirable if you could record a claim on the object that you're intending to mine. You would probably have to get there first. You would actually have to have a spacecraft on that asteroid before you could claim it. But then you could say, please keep out of my way. This is the thing I'm going to be working on. Don't mess up what I'm doing. So that would be a very valuable service for some international agency to serve as a claim registry. They're not necessarily regulating or planning any of these activities, but they are serving as a place where the claims can be registered and certified and used as a basis for law.
So that would be a whole new set of laws and regulations, but it's similar to how in the US it was one of the first countries really to have patent offices and also things like mining claims and so on that now are very common.
Yes, and it would be highly desirable if the United States Congress would get together and establish a claim registry. And that claim registry would then be accessible to anybody in the world who has landed a spacecraft on an asteroid and has the desire to carry out some kind of economic operations on it. So there are dozens of space lawyers in the world already who are mostly concerned with liability issues, but they're also now very much interested in the legal regime for space resource use.
And the claiming of
anybody who's interested in law might find it interesting to get on Google and look up space law and see what's happening right now. There's a bill pending before Congress that would essentially legitimize commercial exploitation of asteroids and provide a claim registry.
Excellent. I have another question here. Is about how do you attach to an asteroid in very weak gravity?
Several possibilities. One possibility is the harpoon, where you actually have a little rocket-propelled anchor that you fire into the asteroid. The second would be to sit above the asteroid as the asteroid rotates beneath you, drop a weighted line onto the surface, and then let the rotation of the asteroid carry that line all the way around the body, and then pull the spacecraft down to the surface. You could then grapple with the line that's already there, tighten it up, and be secured by essentially a belt around the asteroid. There are other possibilities depending on the nature of the asteroid. It may be possible to use magnetic grappling to secure yourself to the asteroid. This is an area where some experiments must be done and where experiments are now being planned. You probably noticed that the little lander on the comet a week or so ago was faced this exact problem: how you secure yourself to the surface. They had their hooks and their harpoons and so on, but they came in at an odd angle, and the grappling systems that they had aboard did not engage properly. But they ended up on the surface anyhow.
Yeah.
Such a simple thing as drilling into the surface is a problem unless you're anchored. Because as anyone who's ever operated a power drill knows, you have to push on it for it to work. So if you're trying to push the drill into the surface of the asteroid, you don't want to push yourself off the asteroid while you're doing it. That's why it's necessary to have some way of harpooning it, or of grappling with the surface, or of securing a tether around the asteroid.
That's right, because that is the second law of motion, that every action gets an opposite and equal reaction. So as you push into the asteroid to drill in, you would be actually pulling yourself out of it.
That's right. That's exactly what the problem is.
Excellent. So yeah, I can see how the belt idea would work. Is there any possibility or idea of bringing an asteroid to Earth, or is it always thinking of the heavy metals, the more valuable metals?
Well, there is a NASA plan afoot. It was originally proposed by a group at Caltech, the Keck Institute there. I was a member of the committee that developed the plans. The idea is to capture a small near-Earth asteroid, bring it back, and put it into a safe and stable orbit around the moon, not around Earth, because we don't want it to get out of control and land on us. Once it's in orbit around the moon, it could be used as a target for manned spaceflight activities from Earth. We could send up a manned capsule to it, explore that little asteroid, and even carry out processing experiments on it. The problem that I see with this mission is that it's basically an excuse for NASA to develop some expensive hardware, and it's not clear whether this would actually give us any advantages in our attempts to make economic use out of near-Earth asteroids. The only things they could possibly are very small asteroids, a few meters in diameter, and a few meters of, cubic meters of material. Does not have any significant resource interest. It's not worth the expense of going to it to process it. So yes, there are such schemes for manned visits to a near-Earth asteroid, a tame, captured near-Earth asteroid, but they have not been funded, and NASA is still analyzing these mission plans to see whether it really does make sense for them to do it. And by the way, it's called the Asteroid Retrieval Mission, ARM, A-R-M, and you can also look that up on the web and find out about that.
Excellent.
The organization behind it is the Keck Institute at Caltech. You can also look them up and find out about them.
Okay, yeah. So that is great. So my suggestion, our time is more than up, okay, and really I'm sorry that we spend a lot of the time with technical difficulties, okay. Are there any other things that you would like to share with the class?
I think there are a few things, probably several hours worth, but
yes.
the first and most important lesson on the academic side is don't be afraid of quantitative science. Don't be afraid of quantitative rigor. It's possible to phrase all kinds of plans in purely qualitative terms, and they may sound wonderful, but until you apply the numerical approaches of science and engineering and economics to these ideas, you don't know whether they make sense or not. So that's number one. there is a sort of a motto which I share with my students from time to time, which is that everything we do, everything in life is an intelligence test. But there's also a parallel slogan which I share with selected audiences, and that is that everything in life is also a morality test. Everything. And we need to think here in terms not just of whether we can carry out this glorious technological escapade, but we need to think in terms of what its long-term consequences would be and whether we can actually do wonderful things for the future of mankind by doing them. That morality test applies in many different levels, and people who enter this business without such a morality test in mind are likely to end up either disgraced or in jail or both. So I strongly encourage all of your LDS folks there to think in terms of what the human race needs in the long term, both material benefits, resources, and spiritual resources, and to dedicate their lives to serving those two needs simultaneously.
Excellent, excellent. Thank you very, very much. That is great advice, and that is one of the things that really we try to emphasize here in the Latter-day Learning School. Every class, we teach academic concepts and gospel principles, how these things actually cannot be applied to our moral self, and how can they help us to develop character, good Christian character for the service of God.
Yes.
Mm-hmm.
May I make a suggestion? Some years ago, I wrote a book called Mining the Sky, which has become popular again recently as it has become clear that there are companies that are interested in doing this.
Yes. Mm-hmm.
The book Mining the Sky has at its end, the last chapter, a vision of the future. And I think your students would be singularly well suited to understanding and reading that last chapter and thinking about it. And I would strongly recommend it to you.
Excellent. We are going to get that and incorporate the study of that chapter in our class. Mm-hmm. That would be awesome. Okay. So thank you very, very much. I appreciate your staying a little longer for this. Sadly, we spent too much time with the technical difficulties. I'm going to close with a prayer, okay? And then we'll call it a class. Is that all right?
Yes, certainly.
Thank you. Mm-hmm. Dear Father who art in heaven, we are very grateful for this beautiful day and the opportunity that we had to meet with Dr. Lewis and discuss these beautiful ideas and concepts about space exploration and being able to use all the things that Thou hast created for us, not only on this earth, but also in the sky. We pray, Father, that Thou may bless our students, that they may be able to develop the skills and talents necessary in order to participate in this adventure of knowledge and exploration and a human exploration getting closer to Thee. We love Thee and say these things in the name of Jesus Christ. Amen.
Amen.
Thank you very, very much. I'm glad that the last part of the class was a little bit more stable. So.
Yes, well, it's a rare meeting that I actually joined 6 times.
I really, really appreciate your endurance and keep trying. Thank you very